folks. We're going to start with example 2. This is 2-1. Okay? All right, so yesterday we talked, we're going to go through example 2 from scratch again, okay? Yesterday we talked about like this being the limit process of doing derivatives, and this is kind of like the ugly way, okay? But limits bridge the gap between limits and derivatives, okay? Between like algebra and derivatives, I should say, okay? So limits is like the baby bridge in between there. And eventually we'll get to stuff where we know how to do it a little bit easier than this by using the power rule that I kind of like previewed with you yesterday, okay? So here's the deal. I'm going to go back to this diagram just to talk about him for a second. You don't have to write this down because you already have it written down, okay? So let's say we're trying to find the slope of the tangent line right here. But I only have 1 point that's on this curve, right? This is my curve right here. I only have 1 point. I want to know that instantaneous rate of change. Like at that instant, what velocity am I going? That's like a slope. Velocity is like slope. And I want to find the slope of that line, but I only have 1 point to do it. Okay, so what we do instead is we make 2 points along that curve, and I find the slope of that one, right? But that one's not going to be exactly the same as the slope of this one. So now I'm going to move that point closer, and I'm going to do this one instead. And I'm going to draw a line there, and I'm going to find the slope of that line. And then I'm going to draw a line that's there and find the slope of that line. And I'm going to keep sliding this point forever to the left until it gets really, really, really close to what the actual slope is, okay? And so what that's doing is that's called a limit. We have our function x, and we want our x value, which is any of these dots that we have going on here. Like this coordinate point right here is x comma something, whatever the y coordinate is. This dot right here is x naught comma something, right? Like the y coordinate. This is saying as x gets closer and closer to whatever this x naught is, as we get closer and closer to the left, that's what the limit is saying. As x approaches x naught, as we get closer and closer to that other point, this is how we find the slope. Make sense? And this is another name for finding derivative, okay? So f of x is just the function that we're given, right? So like we did like x squared, okay? That's what f of x is. F naught, or f of x naught, is just the y coordinate right here, this guy. X naught is this coordinate here. Okay, the actual point, all right? We're going to see this again here in a second. So we're filling all this stuff in, and then we're doing some things, and then we're trying to figure out what the slope is, okay? But that's what the limit does. As this point right here gets shoved to the left, what is that slope approaching?
So what do we plug in for x naught?
X naught is the point that they give you right here on the curve, okay? All right, so we'll get down to here, all right? You guys have this filled in, so just watch, okay? The two things that they give me is the function itself, which is y equals, I'm going to call it f of x equals 2 over x. That's what he is. And then they give me the point 2 comma 1. All right, we know the answer. This is what the answer looks like. We want to eventually do this without having to look at the graph, but this is what we're doing. So this is my curve, 2 over x. He looks like a boomerang. And here is my dot, okay? This is the point 2 comma 1. Those are the two pieces of information they give me. I want to know what the equation of the tangent line is at this point, okay? Now, an equation of a line is y equals mx plus b. And when we find y equals mx plus b, the first thing we find is m, which is the slope. So I need to find the slope of this guy, but I can't find slope unless I have 2 points. Or unless I do that limity thing, right? Where I start sliding and making like secant lines, and I start doing that, and I start sliding him toward that point, right? I want to use that to find m, which is my slope, okay? So if I do that limit thing, the formula for that was the limit as x goes to x naught of f of x minus f of x naught. This is like y2 minus y1 over x2 minus x1, okay? The y values minus the x, or on the top, the x values on the bottom. That's how he looks, okay? All right, your x naught is this guy. X naught is going to be 2. F of x naught is going to be 1. You see that? F of x means y, right? So x naught is that. F of x naught is 1. Got it? That's your point that we're looking at, the point that we're focused on, okay? All right, so here's the deal. We're going to start doing this. The limit, as I'm filling stuff in. What was x naught? 2. So we're doing the limit as x approaches 2, and then we want to fill this stuff in. What is f of x? 2 over x. It's just our function, right? 2 over x, okay, that's what he is. And what's f of x naught? 1, right here. We said that was that, okay? X minus x naught was 2, right? That's filling those values in, okay? Now, All I need to do is find the limit because this is going to give me the slope right here. It's y2 minus y1, x2 minus x1. That's just going to tell me what the slope is of my line. But the problem is I can't plug 2 in because we're going to end up with 0 in the bottom. We can't do that, right? So here's what we're going to do instead. We're going to, yesterday we started doing this. We simplified the top, okay? So I have 2 over x minus 1, and I want to get a common denominator, right? So x is going to be my common denominator. If I change 1 over here to something over something, this would be like x over x, right? And then I have my common denominator as x. Do you see that? 1 is the same thing as x over x, okay? Questions as to how we're doing this so far? If I combine them under one roof, x is the bottom, on the top is 2 minus x. Do you see how that works? I've combined them under 1, okay? And then x minus 2 is just chilling on the bottom, and I'm going to put him over 1 because that's his denominator. So we have like a fraction over a fraction. Got it? Okay? Now I'm going to keep flip him to the top. So multiply by 1 over x minus 2. Okay? Now, x minus 2 is not the same thing as 2 minus x. But what we can do is we can take this guy and we can pull a negative 1 out. Right? And if I pull negative 1 out, I get negative 2 plus x.
Which is the same as x minus.
Right? If I pull a negative 1 out, I get that. And that is the same thing as x minus 2. Those two can now cancel.
So we have negative
Okay?
1 over x.
Right? So now, on the top, I've got negative 1 times 1, which is negative 1, and I have x on the bottom, which is x. Okay, so that's what he simplifies to. This whole thing right here that we just did, this guy, simplifies to negative 1 over x.
What happened to
I am finding the limit as x goes to 2 of negative 1 over x. That's what he simplifies to. What happened to what?
Oh, never mind.
Okay? Are we good so far?
Yeah.
Now can I plug 2 in? Yeah, if I plug 2 in, I get negative 1/2. Okay, what does negative 1/2 tell me? That is the slope, right? y2 minus y1 over x2 minus x1. That was the slope, okay? So even though I only have 1 point here, by doing the limit process, by sliding that other point closer and closer, I can use 2 points, and I can find what the slope is. Make sense? Negative 1/2. That's what he looks like, okay? So I have found the m part, and I have, this is where we left off yesterday. So if you want to pick up here, if you have not already filled this in, we have 1/2 x, and then all we have to do is find b if we want the entire equation of this line, right? So I know that the slope is 1/2, and I need to find b. How do I find b?
Plug it in.
Plug it in. Let's plug 2 in for x and 1 in for y. 1 equals negative 1/2 times 2 plus b. This is just like algebra.
Yay.
Yeah. Okay. What's negative 1/2 times 2? This is negative 1. Okay. And if I add the 1 over, what's the b going to be? 2. So final answer.
Hang on.
Okay. Go ahead. You're fine. You're fine. I'll slow down. You guys don't have this written down already yet.
Yeah, all we're doing is just finding out. Okay, got it.
We're just finding b. So final answer, y equals negative 1/2 x plus 2, which is my b. That's what the slope of that tangent line is. Good? Yeah, that wasn't too bad. We like that. Maybe we like that. I don't know.
Whose is it, you guys? If you drop them. We're missing a good chunk out of our class.
You're missing a I know we are. I know we are.
Pause. We should pause.
Okay.
I thought it would make more sense today, but
We're going to do example 3 now.
it's not.
But I don't want to do it 3 times in a row. I want to do one of those. Pick 1, 4, or 9. Which one would you like to do?
Well, if we do one, we could just multiply.
No. I don't want to. Let's do 4. I don't like using 1 because like 1 is just too generic of a number. Let's do.
So the middle guy. X9 equals 4. Isn't that what the one?
Let's do 9. I want to do 9. Let's do 9 instead. Okay. All right. So over here, 9 is this guy right here. Okay. If you look at the graph again, we won't have the graph when you go to do this in real life, but we have the graph. And what we're trying to do is all that we're trying to do is this curve is the square root of x, and all that we're trying to do is we're trying to find the slope of this line. They have the answer written. What's the slope at the point 9? What is his slope? 1/6, okay? If we were to do 4, what's the slope at 4? 1/4. What's the slope at 1? 1/2. Okay, so we're not going to do 4. We're not going to do 1. We're only going to do 9. So we know that our answer should end up being 1/6. Got it? Okay, so let's see what we get here. All right. I am trying to find the limit as x goes to x naught of f of x minus f of x naught over x minus x naught. Okay, so we have to figure out what x naught is. Okay, this point right here is 9 comma something.
2.5.
Okay, 9 comma what? What is this dot located at? 9 comma what?
Oh.
Josie's right. Did she say 3?
What? What are you?
How did she
on,
get
Lucy?
3?
I looked at the graph.
The square root of 9 is 3, or she looked at the graph, right? Okay, so this point right here is at 9 comma 3, and 9 comma 3 is my x naught and f of x naught, right? That's those values. So boys, you're listening to this. X naught is 9, f of x naught is 3. That's the point that we're looking at. Okay?
Oh,
Got it?
Wait, what? She squared something? Yeah, she squared 9. Or she took the square root of 9.
Took the square root of 9. To find the y coordinate, right?
Oh, yeah.
The function is y equals the square root of x, right?
Yeah.
So I took the square root of 9 to get 3. Okay?
I looked at the graph.
She just looked at the graph, like to figure out, like, boop, 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 boop,
Yeah,
it's
I
at 3.
wasn't smart. I didn't go like.
That's okay.
Oh.
Yeah, hey, you're supposed to lie to us and say, yeah, that's exactly how I found it, right?
How I did that.
Okay, now let's fill stuff in. The limit as x goes to, what's x naught?
Where did the
9. The limit as x goes to x naught, which is 9. Okay,
Square root of x.
f of x is
Square root of x.
the square root of x. F of x naught is
3.
3. That's the y coordinate, right? F of x naught is the y value. This is the x value, okay? Over x minus
9.
9. And we want to do that stuff to it,
Oh,
right?
we can square the top, which would make it x minus 9.
We can't square we can't square it.
do that.
We can't do that. Squaring
Because
doesn't
then
keep it the
it'd
same.
be the x
But we
Plus-
put it
Okay.
squared, then the square root
So-
is
minus.
This guy, just in review, this guy is going to tell me the slope, right? That's why I'm doing that. That's why I'm doing this limit, is so that I can find the slope at that point. Got it? Okay, I'm trying to find the slope. Luke, what are you
just
doing?
like squared the.
Can we just
What are you doing? You're distracting Eli. He's trying to listen. He's trying to listen.
No, he is not.
Eli, listen. We're trying to find the slope.
Here
Here we go. Slope at that point, all right? Now, can I plug 9 in? No, so we have to do a...
Stupid.
So
A
you
strategy.
square the both tops.
No,
You
we
don't
can't do
square
that.
them together,
Can you
you just
conjugate?
square them.
Can we conjugate?
Yes.
Yes.
Yay.
Let's multiply by the conjugate. The conjugate of the
Hey, I got it right.
top. The square root of x
Plus 9.
plus 3. And the square root of x plus 3. Okay? Got it? This is going to be nice. This is going to be so nice, folks. Oh, man. Okay? All right, here we go. All right, square root of x times the square root of x is x. The square root of x times 3 is 3 square roots of x.
But I can't.
And then minus 3 square roots of x. So if you don't want to put that in there, you don't have to. What's negative 3 times positive 3? Negative 9. Okay, on the bottom, don't
Leave it.
foil it.
Yeah, because we can cancel that out. 1 over
Then we've got x minus 9 down here on the bottom. And we've got the square root of x plus 3. There you go. Okay, so on the top, we've got x minus 9, but it cancels, right? See, you guys, see here, look at you got it already, okay? This is this guy, you see? And now I have the limit as x goes to, what are we going to again, 9? 9 of, what's left on the top? 1 over the square root of x plus 3. And now I plug 9 in. Okay, what's the square root of 9 plus 3? 6, so my slope is 1/6. Got it? Okay, now here's what I want to do. Okay, before we move on to the next one, are you ready? Before we move on to the next one, I want to. Shh.
There's a lot going on.
I'm gonna kick you out if you don't be quiet.
Oh wow.
Okay, 1/6 we just found is the slope. Let's say, you gotta listen. Let's say I want you to find the equation of that line right there. The equation of the tangent line. Not just the slope of the tangent line, the equation of the tangent line. How do you do that?
You plug it in.
Plug what in?
Y equals.
Y equals, we know m plus b. What are we plugging in?
Y and X.
9 and 3, right? So 3 would go in for y. 9 would go in for x. What's 1/6 of 9? 1.5. So this is 3 equals 1.5 plus b if you put it as a decimal. Subtract 1.5, what's b? B is 1.5, okay? So, final answer, what's the equation?
Y equals 1/6 x plus 1.5.
Plus 1.5. What's 1.5 as a fraction? Let's switch it back to fraction.
3
3/2. There you
But
go.
I like 1.5.
I agree, but if you're gonna do 1.5 there, we better make 1/6 decimal, and 1/6 is a
Points
repeating decimal. It's 0.16 repeating.
Oh, yeah.
And I don't like 0.16 repeating to like write it out. I'd rather you leave it as 1/6. So
We did
there's that. Hey, look at that. So that's the equation of that line right there, as ugly as it is.
Yay.
Good? That's how you find the equation of the tangent line, okay?
That was
And
the
again,
easy part.
tangent line, this is like the instantaneous rate of change. So take this into consideration. Let's say this is me speeding up in a car. I'm gonna erase stuff. Let's say that this is me speeding up in a car, because this is like exactly what would happen, right? Do you see how this is like curving out? Okay, we're speeding up in a car. The way that this function goes is it's like curving up like this, which shows that I'm like increasing my speed faster here, and then I'm kind of leveling off, right? You see how that works? Increasing speed rapidly to begin with, and then leveling off. Okay? So, that's the way that this works. 1/6 is kind of leveling off. So we're talking about the instantaneous rate of change. At that exact moment, what's my velocity? Because it's going to be different than my velocity at this exact moment. And it's going to be different than my velocity at this exact moment. Here I'm speeding up faster than I am here, right? Or we could go one step further and say, okay, what's my acceleration at that point? Okay? Out of those 3 points, which one's going to have the highest acceleration?
The first one.
The first one, right? I'm accelerating faster at that point, right? I'm speeding up faster at that point. That's acceleration, okay? So we're looking at that and we're saying instantaneous rate of change. That's what a tangent does. Instantaneous rate of change. Got it? Beautiful? Okay. Velocity. Here we move on down to velocity. This is exactly what we're doing, okay? Let's go to, let's just bump to example 4. Let's just see what we're doing here before we go up to any formulas and stuff.
You know where I crashed?
Yeah, let's do this.
Point
Example 4.
one- Or 0.01 seconds.
Oh,
155 miles an hour.
yeah.
Well, I got pulled over by a cop.
Yeah, see,
Yeah,
cars are
well,
just
Cater got
traumatizing.
dropped off a bridge.
Yeah,
What?
Cater got dropped off a bridge today.
What?
Cater.
Who?
You don't know Cater?
I don't know who that is.
Inside joke.
I'm so like not focused right now.
Okay. Okay,
Oh,
I'll send this to you.
Carter in the physics test.
Yeah.
Okay. All right, example 4. Let's hop onto this one. Suppose that S we talked about yesterday is the position function.
Oh, yeah.
Position function. So, and this is a parabola that's facing down. Shh. Do you know how I know this is a parabola facing down? Negative 2x squared is what he is. Okay, so this is a parabola facing down and he's looking like this. Okay, that's what he's doing. Do you know what height we're starting him at?
1.
1 meter in the air, because that's the y-intercept. So that's what we're kicking him off like this top part here, okay? That is the function of a particle where s is in meters and t is in seconds. So 1 meter is where we're forcing him off, and then the x-axis is in seconds. How long does it take to hit the ground, right? Find the average velocities of the particle over the time interval, blah, 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 blah. Okay, the average velocity.
Yeah, I hate
Okay. So let's look at this.
Distance divided by time.
Change in position, time elapsed. All right.
This is literally
0 to, from 0 to 2.
1 meter divided by however many seconds.
Kind of. Okay, here's what part A is. Okay, don't look at 0, 2 and think that that's a coordinate point, like an x and a y. Those are 2 x's. So they're saying when the time is 0 and when the time is 2. That's my starting and my ending. This is start and this is end. That's what they want me to do, okay? They want me to find the average velocity from my start to my end, okay? So if at a time of 0, what's my velocity going to be? Or what's my position, I should say? If I plug 0 in, I'm at 1. S equals 1, okay? If I am at 2, my S is how much? If I plug 2 in, 1 plus 10 minus 2 squared, 8? 1 plus 10 minus 8, what's that?
11 minus 8 is
3? So now I'm at 3, okay? I want to know the average velocity, okay? So I am covering a distance of 2 in 2 seconds. You see that? I do like this guy minus this guy over this guy minus this guy. Like y2 minus y1 over x2 minus x1.
Which ones are the Y's?
The y's are the s's, the output values. Y is always the output, okay? So 3 minus 1 over 2 minus 0. I am going 2, what is this, meters? 2 meters in 2 seconds. So what's my velocity? What's my average velocity?
1 meter per second.
1 meter per second, right? If I reduce that, 2 over 2 is 1 meter per second. So from 0 seconds to 2 seconds, I'm going an average velocity of 1 meter per second, okay? Now, here's my question for you. This was me going 0 to 2 seconds. Let's say I go from 0 to 3 seconds. Do you think my average velocity will be more than 1 or less than 1 if I'm going 0 to 3 seconds?
Less.
Do you think it'll be less than 1 meter per second for velocity? If I'm going from 0 to 3 seconds.
Yeah.
The average velocity.
Oh, wait.
The average velocity.
0 to 3 seconds?
If I'm going
Well,
0 to
we're
3
doing
seconds.
negative,
Here,
right?
this is 0 to 2 seconds.
I
Right?
guess less, I don't know.
Oh, no, so bigger.
If we're going
No,
down?
it would be less, wouldn't it?
No, it'd be bigger.
No,
I change
because
it,
then
it's
you're
bigger.
What happens the farther you fall?
The faster you
faster
go.
The faster you fall. So if I'm falling longer from 0 to 3 seconds, my average velocity is going to go up because I'm going to be going
Okay, that was
faster
my
at 3
initial
than I am
Yeah,
at
that
2.
was my initial
Does
guess.
that make sense? Okay? So from 0 to 3 seconds, I'm going to be having an average velocity that's more than 0 to 2 seconds because I've been falling longer and I've been falling faster. Okay? Let's go from 2 to 3. So given that information, from 2 to 3, do you think he's going to be more of a velocity or less than a velocity?
Less. Oh, yeah, no, there's less distance between them.
My turn.
From 2
Well,
to
it doesn't matter. We're going to divide by 1 then. Right? Instead of dividing by 2 seconds, we're dividing by 1 second.
More.
But do you think the speed,
More.
this is average speed. Do you think my average speed is going to be faster between 2 and 3 seconds?
Faster.
Or average
No,
speed between 0 and 2 seconds?
Because you've been
That
falling for
was-
like the 2 to
Because
3.
you're reaching-
You've
because
been,
you're
it's been
accelerating.
longer, right?
Yeah.
So faster.
So faster is what I'm guessing. If you go 2 to 3 seconds, 2 is my start, so at a time of 2 versus a time of 3. Okay? Let's figure out what S is. We already figured out what S is at 2.
Oh, yeah.
If we plug 2 into our function, I gotta go over here. 1 plus 5t minus 2t squared. Okay, if we plug 2 into that thing, we got 3. If we plug 3 in there, 1 plus 15 minus 3 squared is 9 times 2 is 18. 1 plus 15 minus 18. Did I do that right? What's S gonna be?
When did we plug in 3?
Because 16 minus 8.
What? Why did we plug in 3?
No, when did we plug in 2?
Over here. Did we plug in 2 over there?
Yeah.
When we did 0 to 2?
Yep,
doing the
yep,
same
yep,
thing we
yep,
did the
yep.
first
We're just doing the same thing, but now we're doing 2 to 3 instead. Okay? You see that?
No.
No?
What's the equation of a circle?
No.
The equation or what?
I'm so tired, we just need a
We go
nap.
back
We're
to the-
just on a new coordinate thing. We're on B now instead of A. We're doing the same thing.
radius
Why
Yeah.
did we do
is
2
11,
to 3 on A? Because A doesn't ask for 2 to 3.
and the center is.
No, 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 no. You're looking at the wrong numbers.
You're saying that's what the answer is? I'll tell you what the answer is.
On A, we were going from 0 to 2. If we plug 0 in, we get 1. If we plug 2 in, we get 3. And now we're doing the slope between those. You see what I'm doing?
So like the numbers they give us go in for T.
The numbers that they give us go in for T, yes. That's my starting time and my ending
These are
time.
your- Yeah, your
Yep, yep. Are we good to go? You see
Yeah.
what we're doing? Okay. Over here, if we're starting at a time of 2, if we plug 2 in, we're at position 3. If we plug 3 in, we're at position -2. Okay? All right.
Is Luke in there?
Yes, he is.
Mr. Iredell needs to see him again, please.
Okay.
Well, we're looking at 3.
All right. Now we do our slope. y2 minus y1, x2 minus x1. What minus what?
Your,
3 minus,
your
or
3
two,
minus
-2 minus 3.
-2 minus 3 over
Ew, that's
3
3
minus 2, which is -5 over 1. So my velocity is like -5 meters per second. You see that? Okay, now here's the deal. This one, my velocity was 1, and this guy, my velocity was -5. So which one is faster?
-5.
The -5. Okay, but why is one positive and one negative?
Because it's
And
going
the
being.
direction.
Yeah, this is the direction. So here, on average, I'm going up 1 meters per second. So what's happening is in the first 2 seconds, oh, they have it right here. In the first 2 seconds, I'm going from here to here, which has an average velocity that's going upward. From here to -2,
It's going
that's going to be an average velocity that's negative because it's typically falling over that period of time. Or I guess from 2 to 3. Right here, it's falling in that period of time. So it's all looking at slopes, right? That one's sloping upward because the rock or whatever, we're launching it upward before it's coming back down. That's why one's positive, one's negative. Do you see how that works? This is, write this off to the side. This is when they ask you for average velocity. They're going to give you 2 points, a starting and an ending. You're going to plug them in and find the position, and then you're going to do the slope, and that's it. That's average velocity. Velocity is how fast he's going. Velocity is distance divided by time. We did the distance divided by the time, right? The position divided by how many seconds it was. Average velocity is what that is. Okay?
Sure.
Good?
No.
Okay, here we go. That was average velocity from 2 to 3 seconds. Okay, so from 2 to 3 seconds, here we are. We are looking at an average of how fast that's decreasing. Do you see my blue line? From 2 to 3 seconds. How fast is that going down? We said that that was -5. That had a slope of -5. I want to know the instantaneous, how fast am I going at 2 seconds exactly? So I don't have 2 points on my line now. I'm not doing average. I'm not doing secant. I'm doing the tangent. And I want to do slope of tangent, which is what we were doing with the limit stuff. So now I'm looking at just 2 specifically. Okay? So here's what we're going to do. The position particle at 2 seconds is whatever, blah, blah, blah. Find the particle's instantaneous velocity or slope at just 2 seconds. Okay? So what we're doing is we're looking at the limit as x goes to x naught of, here's this function again, f of x minus f of x naught all over x minus x naught. Okay? Now we've got to figure out the 2 things that I need are my point, which is something, and I need my function, my f of x. That's what I need. Those are the 2 things. My function is 1 plus, I'm going to call him x. Can I switch to x's?
Yeah.
Okay, I'm going to do that. Okay, that's my function. Okay, what's my point? What's my point that I'm going off of? 2 comma what? 3. If I plug 2 into here, I'll get 3 out, right? Or just this point right here that we're looking at, okay? Okay, so this is my x naught and my f of x naught, okay? That's what we're looking at. We're looking at instantaneous, which is that slope of the tangent line, right? The limit as x goes to x naught is 2, and now I need to plug stuff in. What's f of x? All that big junk. Ooh. Okay, there's that. Minus, what's f of x naught? There's this guy. What's f of x naught? What, 3? 3 over x minus 2. Okay, all right, here we go.
We multiply by the
Hold on,
conjugate.
can you zoom out?
Yeah.
Okay, I'm zooming out. I'll pause and I'm zooming out. I'm just plugging stuff in. So like this guy went in for f of x. This was my x naught. This is that guy. This is that guy. We're just plugging in those 4 pieces, right? Those are my slopes and stuff.
After this one, is this a good stopping point?
Maybe. Maybe, yeah.
Because we just have the
Yeah.
next page.
Okay, are we good to go?
Front and the back front.
All right. Now what shall we do?
Multiply by conjugates.
I don't like
Yeah.
that.
No?
Let's simplify the top. Can we move? Can we do the 1 and the minus 3 together?
Go right.
What?
Pause.
What?
I'm going really slow.
Negative 2x squared plus 5x, and then what? Minus 2? All over x minus 2? Okay.
Just simplifying the 1
Yeah.
and the 3 because they
Oh.
don't squares or no.
Okay.
So
All right.
just simplify?
Now, can we do the limit of that thing as x goes to 2?
No.
Can I plug 2 in? No, because I'm still going to have 0 on the bottom, so I got to do something with this. So go down to our checklist. We had our, I should leave that up there on the board. Our checklist
Yes,
for limits.
please.
Okay, I should. I'll put it back up there here in a little bit. Okay, so out of our checklist, number 1, plug it in, not going to work. Number 2, can we factor the top of it and cross some stuff out?
Yes.
Possibly. What is the top?
Complex.
He's a complex trinomial. So let's go over here. I'm going to do some scratch work.
Boo.
Okay? Negative 2x squared plus 5x minus 2. Do you remember how to factor a complex trinomial? Luke's not in here. He came to ask me this the other day. How do you do this?
What goes over there? Then?
A times c. What's negative 2 times negative 2?
4.
4. What can you multiply to get 4, but when you add them, give you 5?
1 and 4.
1 and 4. Okay, so negative 2x squared plus 1x plus 4x minus 2. I break this 5x down into those 2 chunks. Okay? Now, I'm going to group, and we do like the factor by grouping thing. Am I going too fast?
And then we take
Yes,
out the
okay.
common
Yep, we take out the common stuff.
So like 2x.
Okay, so what should we pull out of the first piece?
2x.
We can't pull a 2x out.
X
Just
first
an X.
X
Negative.
and let's take a
Oh,
negative
yeah,
with it
just
as well,
negative
right?
Negative X.
And so he will be
2x.
2X.
2x minus 1, okay? And
Take
second
out a
piece,
2.
if I take out a 2, a positive 2, we have 2x minus 1. Yeah? Okay, so my pieces are
2 minus
negative
x.
x plus 2 and 2x minus 1, okay? Now hold up.
All over X.
This is x minus 2. So hold on just a second. I want an x minus 2 to come out of there. So instead of like that stuff, I'm going to pull a negative x out of here. So let's do negative 1. And this will be x minus 2. And this will be 2x minus 1. Can we do that? If we pull a negative 1 out of that guy?
But you only do it to
Only do it to the first one. Only do it to the first one. Yep. If we would pull 2 negatives out, that would be a positive. So that wouldn't
Negative
work
3.
either. We want to just pull it out of 1. Okay, so now
No.
this whole chunk right here is negative 1 times x minus 2 times 2x minus 1 all over x minus 2. Okay, now what?
Cancel.
Cancel.
Oh, can you do that?
So negative 1 times 2x minus 1, that's what we have left over. And we are finding the limit as x goes to 2? Hey, man, oh man. Instantaneous rate of change. If we plug in negative 1 times 2 minus 1, which is 3, negative 3?
Yeah.
Negative 3 meters per second. Okay,
Oh, I'm
so
running out of them.
on average, from this point right here, let me get yellow. On average, can you see my little yellow stick here, right here? On average, from this point to this point, he is going negative 5 meters per second. But at this point exactly, at this place exactly, he is going negative 3 meters per second. Just at that point. That is his instantaneous speed. So, like, that would be like the equivalent of me saying, like, from Hastings to Lincoln, I'm going an average speed of 70 miles per hour, right? But at the York exit exactly, how fast was I going? Does that make sense? At this place exactly, how fast was I going? And it probably isn't going to be 70 miles an hour. It's probably going to be like maybe 68 miles an hour or something like that, right? At that instant, how fast was I going? Versus over a period of time, how fast was I going? Got it? Make sense?
Good stuff.
I like it. That's a lot. Okay. All right, there you go. I do have homework problems up here. There are 5 of them. 2, 12, 16, 26, 28. I'm going to guess that you could probably get through 2, 12, and 2, 12, and 16 right now.
Alright, can I use the restroom?
That wouldn't be a bad idea to do that. 2, 12, and 16.
This is
Okay, I'm going to the bathroom.
Okay. All right. I'm shutting you off. Goodbye, people.